Hello, in this video I'm going to show you how to build my modified version of the open build C-beam linear actuator. There's a parts list just shooting up the screen there. Obviously I'm going to put the parts list in the description of this video as well. This design uses mini V-wheels as the normal open build C-beam actuator does. I got these from China at a very reasonable cost, including all the bearings and spacers, etc. These are my own laser cut acrylic parts to my own design, but based heavily on open builds. There's some bolts here which I actually had to modify myself because the head was too large. You should really just buy special bolts which maybe have a hex key fitting, which have a small head already, but I discovered that by putting the bolts in a pillar drill and using an angle grinder, I could just reduce the size of the bolt head considerably quite quickly. Not quite as quickly as it looks like here, but you can see there's a normal bolt compared to one that's been through this process. And the dimensions for the coupler, quite important this, 18mm by 25mm. There's 8mm collars and thin washers, spring that doesn't fit through that hole, super glue, solvent cement, socket set, Allen keys, drill taps, drill. So to start with the build, I'm going to take some M5 nuts and bolts. These weren't on the parts list, they're just to help you attach these parts together. So I'm just taking off the protective film on the inside surface of each of those parts, placing them together, trying to get them as even as possible, trying to get the edges to line up as well as possible, and just bolting them together securely. This is in preparation for applying the cement between the two parts. I'm just going to do the same thing on the two end plates. Just bolt them together nice and securely and make sure all the edges are flush as much as possible. I'm going to take some of the solvent cement, get it on a brush and just run the brush along the edge of the parts and let the cement get drawn into that gap there. Obviously this next shot is after the glue is dried. It doesn't take long, just a few minutes, and then you should find that all of those three parts are welded together. And countersinking that particular hole on both of the end plates, and that's so it fits this screw. This is an M3 tap. I'm tapping the holes for the opto-endstops in the two end plates. This is an M5 tap. I'm going to tap the two 4.5mm holes on just one of the end plates. You can do both, but there's no point. Just removing the protective film on the end plate and fitting in the 8mm internal diameter bearing. Just going to do the same on the other end plate. It should click into place and it may just sit there. The hole is such a small tolerance. I'm taking some aluminium foil and I'm going to glue that onto the two end stop flags on the gantry plates using Superglue. That's because this acrylic is actually transparent to infrared light, so without the aluminium foil the acrylic would not trigger the end stop. Just cut that strip and I'm just forming it onto the shape, cutting it off. Now I'm taking the Superglue or Araldite, as I'm using in this case, just applying it a tiny dab onto the end stop flag and gluing on the aluminium foil. I did get quite a lot of super glue on my fingers. This isn't perfect, but if I'd used gloves it would have just I would not have been able to do this properly. So there you go, I probably poisoned myself. This is the anti-backlash nut trap. You see the first one that I tried to fit the nut in was really tight. That's and the rest of those other three are loose. The first one that was the tight one you need to use an M3 tap again, and the rest of the holes don't need tapping. I removed all the protective film and just pushed that nut into the tighter hole for the nut. I'm just lining all these up in order now, and I'm going to bolt them all together. The holes were pretty tight, even the untapped holes, to get that bolt in, but with an impact driver it seemed to come together pretty well. And of course you want this to be tight, you want it to be held together really securely. Just to show you how this nut trap is going to work, I'm just going to fit the spring in there, and then you can see the other nut going in on the loose side is free to move a little bit. Now, I've taken the rest of the protective film off one of the end plates, and I'm just going to bolt it in place on the C-beam. The C-beam I got came tapped. If yours isn't tapped, obviously you need to tap it first. Now I'm going to assemble the mini V-wheels. The bearings push in, they're very tight. Once you've got one bearing in, you put the little shim in there and trap it under the other bearing, and that just stops them pushing together too hard when you tighten the bolt up, and that would obviously jam them. There, all the V-wheels are done. I'm now going to attach them onto the gantry plates after I remove that protective film on the bottom. First I'm going to do the eccentric spacers. I'm just going to clip that into the bottom of the gantry plates. Just do the other one as well. Next I'm going to slide the bolts through. And then comes another shim just like the one in the middle of the V-wheel. And next the mini V-wheel itself, and then a nyloc nut. Just do that finger tight there. I'm not going to show you myself doing the other eccentric spacer. Now here are the normal spacers. Just exactly the same procedure as before. Bolt through there, little shim, then the V-wheel, and then the nyloc nut, and just do it finger tight for now. On the normal spacers, I'm actually going to tighten them up a little bit more because they don't really need to be adjusted at all. You just need to do them up just tight enough so that the V-wheel still spins freely. I'm just going to try to fit in the anti-backlash nut trap there. You can see it doesn't quite fit. Now it's better that it's tight than too loose. I'm just filing down some of the mating faces there just to get a really tight fit, but so that it does just click in there. Now that's looking good. It's all flush with the top surface as well, and it's staying in there of its own accord. I'm just adjusting the eccentric spacers now. This is a longer process than I've shown, but basically you want to adjust them and obviously then tighten them up so that the gantry plate moves easily within the C-beam, doesn't wobble from side to side. I'm going to assemble the anti-backlash nut trap. I just screwed in the threaded rod, added the spring, and now I'm going to screw in the threaded rod a bit further to catch the nuts on the other side, so that it's kind of held tightly. The threaded rod is held tightly between those two nuts. Obviously it would take ages to screw that on manually. I'm using a drill to just get the nut trap roughly kind of halfway up that threaded rod, and then I'm going to reattach the nut trap into the gantry plates. It's still fitting very tightly, and then I'm going to introduce the gantry plate onto the C-beam again. Next comes the 8mm collar. and an 8mm thin washer. I let the threaded rod protrude about 5mm from the end plate and then secured the collar. Here's the collar and the thin washer going on the other side, and I'm just attaching the end plate there in the same manner as I did before. Next I'm just going to slide the collar up to that end and secure it with the grub screw. Next I'm going to fit the end stops. Those just slip through that hole there, and then M3 by 10 screws just secure them. I forgot to show you, but I put the 8mm coupler on the end of the threaded rod, and now offering the stepper motor up to it and using the spacers to work out exactly how far away the stepper motor should be from the end plate. And then I'm securing the grub screw on the other end of the coupler. Next I'm going to put the longer M5 screws through those spacers and just screw them on, making sure to get the motor kind of straight and even on the end. That's harder than it looks, and I'm already working on a modification to make it easier to get the motor lined up properly. But as you can see, the coupler spins round fairly freely. That looks like a good one.